Okay, so the recording has been started. So welcome guys to this workshop on microservices, Docker and containers. Before we get started, I would just like to know about the background of you people joining so that I can discuss around that. If you could help me with your background, just in few words, one word or two words, just a background or your skill sets in the chat window, I can go over them and I can just get a good idea of this audience of this forum here. Please help me with that. I assume that most of us are performance testers, but I just want to understand, is there any other people who would be joining, who have joined this particular workshop? Please use the chat option which you see uh, and help me understand. Yeah, we'll wait for 2 minutes. Am I audible to everyone? Am I not audible? Yeah, so please use the chat window. Right, just these kind of things like Mohit has mentioned performance tester with Jmeter. Yeah, that's all I need to understand about the audience so that I can base my discussion on that. 3.5 years, good. LoadRunner, NeoLoad, Aman, good. Vipul, performance tester, good. Naresh, performance engineer, perfect. Yeah, guys, please. If you could be quick, performance testing with LoadRunner, Jmeter, Raj, perfect. Performance testing, learning, Santosh, perfect. Performance testing using Jmeter, Jenkins, Grafana integration, Abhi, thank you, good to know. How about others? Right, I do see most of us are performance testers here, and few of the folks are performance engineers. That's good to know. Right, I'm into performance testing since 10 years, LoadRunner, Jmeter, P 3 years. Okay, Lakshmi, good to know about you. Meghna, performance testing, new load, Jmeter. Yeah, good. Yeah, that's I think most of us, majority, like almost I can say they are from performance testing background. So let me just be context on that. So before I get started, let me just introduce myself. This is Roshan. I have around 15 years of experience in IT, mostly predominantly into performance testing. Started my career into performance testing, engineering. I was into Java development as well, into automation as well, Python, shell scripting, uh, different used tools like Jmeter, LoadRunner, RPT, right? And used various automation tools like Selenium, different frameworks. I have worked on various technologies, right? I'm a certified cloud professional, been into performance engineering for quite some time. Currently, I'm a principal of performance engineer and a site reliability engineer with one of the reputed, I'm one of the consultants, and as a part of hobby, I do like teaching and sharing my knowledge. So this is the agenda for today's, guys. We'll be going over the microservices. I understand most of you are performance testers, so you when you say JMeter, LoadRunner, I assume that you're mostly dealing with the HTTP, HTML protocol, like web-based protocol. You must be having some UI, right? But where the world is moving towards, we are moving towards microservices. We are moving towards REST endpoint. How many of you are testing API testing using JMeter or any other tool, NeoLoad or JMeter API testing, where we are dealing with microservices and things like that? I hope few of you must be doing that, right? So yes, Aman is doing that. Perfect, good to know. Right, Meghna is also doing that. So if you look at the current, Lakshmi is also doing that. Abhi is also doing that. Perfect, good to know. Yes, because I understand, but if you look at just 3 to 4 years before, like I would say 5 years before, very few people were working on API testing. Most of the applications were web-based applications where we had the UI and we asked to automate or script in when we had the UI, right, the user interface, and we uh, do scripting, we develop scripts and performance test analysis, and we do all sorts of troubleshooting and engineering activities. But nowadays, the world is moving towards microservices. When I say microservices, So we need to understand what is microservices. So when I take monolith application, so our agenda for today's discussion is around that. We'll understand the differences between monolith application, what is microservices, differences between monolith and microservices architecture, the how do we the runtime environment for microservices, where do we host microservices, how do we run these microservices. We'll understand that we run in containers. We use container engine like Docker, right? And if we need to orchestrate things, we use container or orchestration engine like Kubernetes, right? We'll get to the basics of that, and we'll try to make the foundation structure basics. Your understanding is strong here. Hopefully, in 1 hour, you'll get a good experience, and then you can use it in your ongoing activities which you are performing in your companies, right? So when I say monolith application, basically, I want you to focus your attention to this. I want to the application layer. I want your focus to be on the application layer. Where if you look at the application layer, in the monolith application, all the business logic resides in one layer. Let's say I'm working with a three-tier application. Okay, let's say I have a web server, I have application server, I have a database server, right? So focus on the application server where all my code logic resides in one layer. When I say all my code logic, so we have when you develop an app in any application, right, you have various modules like accounts. I'm just taking one of the example. Let's say I have a bookstore app, or if I have, let's say if I have a Flipkart or retail application, so I must be having some modules, right, payments or search module or add to cart module, right, place order module, right, checkout module. I will have these kind of modules, right. uh, I need to check the availability of a particular product, so I will have a lot of modules. So when I put all the code in one layer itself, when I say all the code in one layer, when I say the code, the functions which you write in for the one module, let's say you are writing F1 to F10, 10 functions in this accounts particular module. And let's say you're writing F11 to F20 a module, let's say 10 other modules in this shipping module. So you're calling the functions anywhere and everywhere. There is a tight dependency. These modules are tightly coupled. You're calling the functions anywhere and everywhere. So what will happen? The major problem with this monolithic application, that even if one of the functions, let's say, stop working, or let's say you have a small bug in one of the functions, the entire application availability can go for a toss. Your application availability could be in danger, is at risk, right? So that's the main problem with this monolith kind of application, where all the code logic resides in one layer, and when the functions are getting called everywhere and everywhere, right, anywhere and everywhere. So we are trying to solve that problem by converting this monolith application into microservices. That's the main idea, so that these modules are interdependent. I would request everyone to be on mute. You can ask the question at the end of the session, guys. I would be giving you ample time to ask you questions. Let me just get the basics of it. We'll come to the question. I request everyone to be on mute for some time, for 10 minutes, for everyone's benefit. Yeah, thank you. So when I'm going to break this application, right, say I'm going to make these modules independent. I want independent, so that even if one of the modules fail for any reason, it should not impact the other module. Let's say, for example, I have Swiggy application, or I have Ola application, right? Swiggy application we use for ordering the food. Ola application we order to book a cab. Let's say one of the module is notification. So whenever you order a food or you book a cab, you get a notification that you have booked your cab, your cab is on the way. So those particular function is being performed by the notification kind of module, right? If I say you, let's say that the problem with the notification, if the problem is with the notification, now you cannot book a cab or you cannot order a food. It doesn't make any sense, right? So those two modules should be independent. That's what the microservices is all about. I want to make my modules independent of each other, so that if one microservices gets impacted, it should not affect the other modules. So that's where we are heading to. And what is the main advantage of it? It is going to make my system highly available. There's a more chance my system will be highly available, because from a performance point of view, yes, you need to have a good performance, but the application availability is also a performance engineer responsibility. You need to make sure design your application. If you talk about it from the engineering point of view, you need to design your architecture in such a way that your application is highly available, because that matters to the business as well. Apart, along with the good SLA on the response time and throughput, the high availability also matters, and this is where the microservices comes very handy, right? One of the disadvantages, let's say, I would tell you the other disadvantage of this monolith application. Let's say I have one search module, let's say my Flipkart, right? I'm going for the search module. And we know that in a retail application, we mostly end up searching for a product, right? What you do in Amazon or Flipkart, mostly you browse for a product, you mostly search for a product. So I know that the search module gets invoked more often than any other modules. So let's say if you run a performance test, you have run like, let's say you have developed scripts, 4 or 5 scripts based on the business use cases, critical business scenarios. You have 5 scripts right now. You're running a performance test, and let's say you found one of the transaction is taking high response time. Let's say the search module, obviously, because if you do a workload modeling, the search functionality, you'll have to give more weightage, and you'll have to put more users there. Let's say the high response time you observe on the search module. Now what you have to do? Now you observe that the CPU utilization is going on the higher side. Let's say that. So what is the option you have? You have to scale up the CPU, the infrastructure, correct? If the CPU utilization is the problem, if you have looked at let's say you have looked into all the thread dump, you have looked into all GCs, and you have come to the conclusion that CPU is the bottleneck, CPU is the contention because of this particular module. What is the option you have? You have to scale up the entire application stack. You have to scale up the entire application server itself. You have to give more CPU and more heap memory to the application server. You cannot do something specifically for that search module. Correct, guys? Are you with me on this, everyone? Can I acknowledge?
Yes.
You right? So you cannot.
Yes.
Right, absolutely. Yes, thank you.
That's correct.
Yes, you cannot do anything specifically that for that particular module. You will have to scale up the entire application server, because all the modules are tightly coupled. You have one jar file or a war file deployed together, right, on an application server. It could you could be using Tomcat or WebLogic or WebSphere, whatever. Your jar file or war file is running on the one application server, and now you have found out that the CPU is the contention. You have no other option but to increase the entire application server capacity itself. Either you do a horizontal scaling or vertical scaling, that's a different thing. But other modules did not require the resources. When I say resources, the CPU, memory, others module was perfectly fine. That SLA was perfectly fine. Only the problem was within only one module, and because of that, we have to increase the entire application stack. It doesn't make any sense. Think logically, it doesn't make any sense. If I divide this into microservices, and if we find a way that if we can deploy this microservice independently, separately, I can only scale up that particular microservices infrastructure. I don't need to worry about the other microservices. Right? And this is one of the major advantages you get in microservices. Other very important advantage, or I would say the disadvantages of one application is that, let's say you have started developing your application. Let's say you started with accounts, and let's say you started with, let's say, Java, okay, or Node.js, or any JavaScript, whatever language you started with. If you are developing a Mons application, your upcoming modules could, let's say shipping, inventory, or let's say you're going to add many more modules in the future, has to be in the same application stack, has to be in the same technology, you have to use the same language, because you have to call the functions. One function has to understand the other function. You cannot use any other language for other modules. You cannot do that. But this problem doesn't have in the microservices. For one of the modules, you can use Java. For other modules, you can use Python. For other modules, you can use Go language. For other, you can use JavaScript. Depending on what suits well for that particular module, you can use that language. Because end of the day, you're exposing the RESTful endpoint and you're calling the other microservices through the REST API. And that's where this web services comes handy, because that converts language conversion is there, because end of the day it's REST endpoint, web services, it will convert and it will understand the payload and the request. So there is no such problem in the case of microservices, and that's where we are heading up to. And that's why you guys are testing API testing nowadays more than often, right, as compared to other days. So a lot of disadvantages, I just list out a lot of disadvantages. So, and all these things are in the benefit of microservices. The advantages are not that great. Single unit of deployment, again, if a jar file is used, yeah, someone says, yeah, you have got 5 jars and I have only 1 jar. Microservices guys are telling, complaining, I have 5 jars, and let's say more of the guys are telling, I have only 1 jar to deploy. But how often you deploy, that's also important. You have to wait the entire quarterly release to deploy 1 jar file. You have to wait for all the bugs till the quarter end, and then you deploy the upgraded version of your code. But in the microservices world, the deployment goes very often. It's all automated. CI/CD pipeline. It's all automated, and the deployment happens much more frequently. And it's easy, lightweight. Jar files are not that heavy. It can just run very easily. And it's just a portion of the same code. So I'm not talking something different. I have the monolith application. I just broke the same application. Earlier, I had 10 modules deployed together. I have a bigger code base. Now I just separated it and I made it separate. I have a lighter code base now for each of the modules. And I can, if I have one issue with one of the code base, I can fix it right there, right there. I can deploy it, and I can get the upgraded version. So a lot of advantages for microservices, and that's why the entire world, entire IT infrastructure is going towards microservices development. We are in this transition phase from last 4 to 5 years. We are in this transition phase where all the development is happening towards microservices. The next question comes, where do we deploy these microservices? So if you look at this architecture, so I'm just depicting that in the cloud. I'm just showing that you have microservices architecture. One of the microservices developed in Java, other in Python, third one in Go language. We are using SQL, we are using NoSQL, we are using all sorts of technologies possible in the case of microservices, but that's not possible in the case of monolith applications, right? So these are the characteristics. If you look at the microservices, so autonomous and specialized, these are the characteristics of microservices, autonomous and specialized. The main advantage we have, because we have made it separate. Accounts, shipping, payments, inventory, all are separate now. All are autonomous and specialized, independent of each other. I'm not calling the functions. Remember, let's say if this particular module has 10 functions, F1 to F10, and this is having F11 to F20, I'm not calling the functions. Let's say F12 needs to call F1. I'm not calling the functions. I cannot, we don't do that in microservices. If we need to rewrite the code, duplicate the code, we may do that for one of the functions or the 2 functions, but should not be more also. If we have more code base, we can merge these 2 modules and make it a one microservices. So that's all of the decisioning factor comes at the top level when we discuss about microservices. How do we separate microservices and things like that, right? A lot of advantages, guys. Flexible scaling, I can just scale up for one of the modules. I did not scale up the entire application server stack. Easy to deploy, frequent deployments, technological freedom. As I told you, one microservice is in Java, other was in Python. A lot of technological freedom. Reusable code, yeah, within one microservice I can still reuse the code. Within one microservice I can still reuse the code. That's the one of the greatest advantage I have. Resilience, right? So what I'm getting, what I'm achieving at end of the day, I'm achieving the resilience, means high availability. My application is less likely to be down, or my user is less likely to have to feel the downtime. They are not going to experience the downtime because of this kind of architecture. And we will talk about a container Kubernetes engine. We'll talk about different how do we create containers and things like that, we'll understand how resilient it will be. If you talk about Kubernetes and things like that, container orchestration engine, where auto scaling things are there, replica sets are there, where we can maintain a stable number of replica pods. We'll talk about those things slightly if there is time. So it becomes, so if you deploy your microservices in Kubernetes using pods and Kubernetes for in the pods, there's less chance possibility the user can experience downtime. A lot of advantages. It's not like we have only advantages. Okay, the disadvantages we have but few, and that too can be managed. So it will be wrong to say there is no disadvantage at all. See, everything has one disadvantage, but it's up to you. How do you manage it? All the disadvantages are manageable. So when I say spawning, let's say you should not create many more microservices so that it becomes a troubling factor for you to manage. You should be, the microservices, number of microservices should be manageable for you. It should not, like if you break your microservices for 100 microservices, difficult to manage. So you should not have that way also. You need to have a logical split, logical separation of the microservices so that it doesn't become a bottleneck for you. Duplicate code, yeah, you may have to write, because as I mentioned, right, you don't call the function, so you basically sometimes end up writing a duplicate code. But again, you have to decide. Let's say two microservices you are coming up, and let's say the duplicate code is more than 40% or 30% or 50%, like more of the codes are getting duplicated. Just merge those two microservices and make it a one microservices. Who is asking you to just create two microservices, that too when you have a same code, 40% or 50% of the code base is same? Why do you need to create two microservices? Let's just merge those two and make it a one microservices. Sometimes maintenance becomes a problem. Again, as I mentioned, if you have too many microservices, so it's a kind of all these disadvantages are manageable. It's not like an architectural heavy or you cannot manage it, right? So if you take care of these aspects, it becomes quite easy for you to manage. Network performance, again, when we talk about how we deploy these pods, we deploy in these microservices. We basically run these microservices in containers, pods. So when we have, as I mentioned, right, so when we have a lot of microservices, so when we look at from the deployment point of view, we deploy these microservices in pods. If you look at the cloud, we have concept of availability zones, right? Data centers. So we should deploy in such a way that the pods are not separated from each other. From one pod is in one data center, other pod is another data center. So if there is two different pods in two different AZs, it could be a network performance delay. So we need to make in such a way that you create multiple pods, but don't create one pod in one AZ and other pod in other AZ. What you can do to achieve high availability, you create multiple pods in one AZ and then another set of pods in other AZ. So that you get high availability also, and you can manage with the network performance also. So these are the disadvantages, few, but it's manageable, right? So these are the some differences between multi microservices. I'll come to the next section. Before, I would like to take up questions. If you have guys any questions, please do let me know. Are you guys following? Are you guys with me till this point of time?
Yes, Raj.
Yes.
Any follow-up questions, guys? Any clarifications you're looking for? Anything? Do let
Yes,
me know.
I have a question.
Sure. Go ahead. Yeah.
Actually, in our application, we are using the RESTful APIs, but while recording the Jmeter script, we need to record the end-to-end flow with all the requests. So why it's not possible to execute the load test with RESTful APIs only? Why we need other requests as well?
So this is not a Jmeter session. I'll talk about that in some other day. If you have trouble understanding microservices, do let me know right now. Let's stick to the topic. Okay. If you have any
Okay.
questions. If you're all okay with the concept part, microservices, we can proceed. All good?
Yes.
Perfect. So the next problem statement comes: where do we host these microservices? Where should we run these microservices? We have multiple options. We can deploy microservices in physical servers directly on the physical server. Back in 1980s, when the software development started, we were deploying our application on directly on the physical server. We were deploying that, and what we did, we wasted a lot of resources, right? And then the virtualization came. We divided the same physical server into multiple VMs, and we are still using the VMs, right? So we have other option. We can run these microservices on the VMs, directly on the VMs. We can do that, but now we are in the phase of containerization. We are further breaking down and making sure that the efficient utilization of the resource is happening. So why we came from physical servers to VMs? Because we wanted to efficiently utilize the resource. We don't want to waste any resource. That's why we created the VMs. And now we are in the phase of containerization. So this phase here, this phase is called virtualization, and this phase we are here right now is called containerization. So we are creating multiple containers in one VM itself. Multiple containers, remember. So let's say I'm just tell you one very example, you'll understand that. Let's say you have a 3-tier application. You have a web tier, app tier, database tier. Let's say that you need 3 VMs. What if I tell you that you can have your 3-tier application in one VM itself? Would you like that? In one VM itself, you can run the 3 tier application what you had, which you were running in 3 VMs. Now you can run the 3-tier application in one VM itself. Would you accept that? Would you take that as a positive thing? Guys, just need your opinion.
Yes, we can.
Right? Because what we are doing, we are doing efficient utilization of the resource. That's what we are doing. We are making sure that every resource of one VM is fully utilized, and then only we are going to the other VM if we need more resources. That's where containerization did, and we creating, and we do that. We achieve that by installing something called container engine on the VM. We install, so we have a VM. We are going to install container engine on top of the VM, and then we are going to create containers. That's what we're going to do. And these containers will host the microservices. And these microservices, what I was talking about, they come in the form of images. Let's say we have Docker images. So we have a container engine. So what I'm going to tell you, that we have this. We have container engine. Okay. We are going to, so Docker is one of the popular container engine. We are going to install the container engine on the VM. We are going to install that. So you're seeing this, right? We are going to install container engine like Docker or Rocket. There are these two are popular container engines out there in the market. We're going to install that on a VM, and we can create multiple containers in one VM itself. Earlier, in the virtualization, I was virtualizing the hardware, the underlying hardware. That's where I was creating multiple VMs. All these VMs needed a separate operating system. You can just collect your application, all your VMs. I hope so. You have all the VMs which you use have operating system, correct? Obviously, yes, right? Whatever you use, Linux, Windows, whatever VM you use, you must be having an operating system. But these containers are lightweight, and they virtualize the operating system, underlying operating system. So in one VM, you have operating system. It's going to virtualize this. That's why when you create containers, you don't need separate operating system for your containers. That's where you can run multiple containers in one VM itself. So we are going to create containers on top of VM because VMs are mature and secure. Just get that. So VMs we have been using from quite some time. So it's not like, so you can also ask, why can't we directly create containers, install container engine on the physical server? Why do we need to, why we are doing this thing in the VM? Because VMs are mature and secure, and it's been proven out from last 30 years, 25 years, we are using VMs. So use the maturity and the security of the VM level, and then we are going to create containers on VM. So we have the best of both the worlds. And we're gonna see how do we create containers and how do we host microservices. We'll just see a demo around that, right? So what we are going to do, we have something called Docker, right? I told you Docker is the container engine which we are going to install on a VM. So let's say I have one VM. Okay, so this is a VM I have in my AWS account. Okay, so this is one of the instance I have created today for this workshop. And let's say this is the public IP of this. So I connected to this particular VM, and this is the private IP ending with 28.111. So I have this private IP. So I connected using PuTTY. You can see this. Let me make it more readable so that you guys can see this. Okay, I hope you guys can see this better now, right? So this is the Ubuntu operating system, Linux operating system I have. So what I can do right now, let me be a root user. I can be a root user, and let me update this operating system. To update this operating system, I know to apt update, and this will update all the packages. And then I'm going to install Docker. So this is a VM. I'm going to install a container engine on top of that. And I'm going to create containers. So let's say I talked about creating 3-tier applications. So I have this is updated now, this operating system. So what I'm going to do, I'm going to install apt install docker.io. So this is going to install Docker. Yes, I want to, that's fine. So this is going to install Docker for me. And if I after this, if I just do a Docker version, you would understand what is the Docker. So Docker is nothing but the container engine. So when you have a physical server, bare physical server, how you're able to create VMs, because you have something called virtualization software installed on the physical server, and that because of that you're able to create VMs. It is like a virtualization software, your container engine, which is Docker I'm installing right now, which is going to virtualize the underlying operating system. That's what I talked about some time back. So you have this physical server, you install the hypervisor or any virtualization software, VMware hypervisor, VMware virtualization software, and then that's when you create VMs. Here on the right side, I'm talking about one VM, and I'm installing something called Docker engine container. Docker, which is the container engine, and then I'm going to virtualize the operating system, and I can create multiple containers, right? So let me just, so it's complete now. What I can do, I can just check the Docker version, and you can see this is, so Docker has two things, client and server. That's how it talks to, right? So I have got both the versions installed, 20.10.7. I have installed both client and server. Perfect, good. So the way Docker works, that we have something called, our microservices are in the form of images. Remember, so I'm going to run microservices. So Docker has something called a Docker Hub. Okay, Docker Hub. If I just show you what is Docker Hub, it's a repository of all the images, hub.docker.com. If you go to this website, it has all the images from popular companies. Let's say if you talk about your MySQL. MySQL is a database, right? So MySQL has released one Docker image. So what MySQL is telling, you can use this image to create MySQL container. Similarly, you have, let's say you guys are talking about Jmeter, right? So even Jmeter has a Docker image. You can run Jmeter also as a container. You don't need to install directly on the VM. You can run Jmeter as a container also. Let's say for different, let's say you have a web server. HTTPD is a web server from Apache. So HTTPD has a web server, and this is the image they have, right? So I can use this as a web server, and I can install this as a container, and I can host my web page. I'm going to show you how do I create containers from these
So
images. Yeah,
I do have one question. Sorry to interrupt you, Roshan.
sure.
In what ways these images are useful as compared to the original softwares? Like as you earlier said, we can install the image of Jmeter instead of the real one. Right?
Okay. See,
So how it will be beneficial for us?
sure. Think from an architecture point of view. I'm talking about architecture. These are all called microservices. See, Jmeter is also available in container image. As a container, you can run as a Jmeter as a container. You can Jenkins, you can run as a container. But the use case, think from an architecture point of view, how your application is deployed. So they have also this release. So this microservices is that popular that this Jmeter and MySQL, every company has come up with their own Docker image. You can use this image to run as a container. See, so running as a Jmeter in a VM would take you less space. First of all, microservices are lightweight. You can run multiple containers of one Jmeter. I'm just giving one example. First of all, it's lightweight. Basically, the end goal of these microservices is to efficient utilization of the resource. Let's say you are going to install JVM directly on the VM. You can run only one instance of Jmeter, but if you run Jmeter as a container, you can run multiple instances of Jmeter. You can use one as a load generator and one as to just run the load. I'm just giving one example, but the use case of it is from the architecture point of view. Look at how application is deployed. I just don't think about this Jmeter is used. You can run Jmeter either directly on the VM, that's perfectly fine. You can just have one dedicated machine to run your load test. Jmeter is a very tiny little role in this, in the entire world of microservices. It is just a container available. I'm here to talk about more about the microservices, not about the Jmeter. And the transition this world is this IT is happening towards microservices. I'm here to talk about that, right? And I'm explaining one of the features of microservices. How do you run this microservices so that you get comfortable when you work with microservices, right? How do we run this microservices? Yeah.
Okay. So containers are basically going to be built up upon the virtual machines.
Exactly. That's what I'm talking about. How do you create containers? So first you need a container engine like Docker. Just now I installed Docker engine. This Docker engine was container, and now I can create containers on top of this VM. I can create multiple containers. I can run a 3-tier application in one VM itself. See, think broad. Don't think from a load runner and just puff Jmeter. It's just a one tool. You can very much go ahead and install Jmeter directly on the VM. It's not a Jmeter session. Think broad, okay? What I'm talking about, think from a microservices point of view. Don't think from a Jmeter point of view. Right?
So, one question here as well.
Sure.
Hello.
Yeah.
So actually, if suppose I install Docker in my Windows system, so how, like, as I know that we generally use like Linux or Ubuntu version for Docker. Yeah. So then, how will be able to create or containerize?
For Windows, see, containers are suited for Linux application. If your complete application stack, let's say I just want to ask you, the application which you work on is deployed in Linux or in Windows?
Both Linux and Windows.
No, like you must have a Windows VM, but your application server, your database server are installed in Linux or Windows or both. You support both.
Linux actually.
Linux actually. That's what I'm telling you. So these containers are suited for Linux operating system, not for Windows. Because of licensing thing, Windows are quite heavy to run microservices, because when you create containers, you don't need a separate operating system, and that is not possible with Windows. Right now, we are not there. IT industry is not there to support containers on top of Windows operating system. We only talk of containers on Linux operating system.
Okay, so in case if I want to like develop something, then for that, if I, because I generally I'll have a system which is of Windows. So then how will I be able to work on Windows with the help of Docker?
See, you can create, if you want to see what is your intention. You want to install microservice, you want to install container engine on Windows VM. This is what you want. Or
Yes, yes. So that I,
no, as I mentioned, right, you cannot create containers on Windows operating system. You cannot do that. It's not supported. You cannot create multiple containers. Currently, the containers are only supported with Linux operating system. That's how it is, right? That's how it is. If you want to virtualize your Windows operating system, you have Hyper-V. You can create multiple VMs. Let's say you have 16 GB of RAM in your Windows. If you have Windows 10, you can use Hyper-V. You can virtualize your Windows operating system. You can create virtual machines of Linux, and you can use those virtual machines to run your install Docker and different create containers. But if you want to directly install containers, Docker on Windows, and you create containers, no one is doing that. No one does that. It's not supported because you cannot create containers. You will understand why am I saying so. Okay, because when I create containers, I don't need a separate operating system. You would not see me installing a separate operating system, because it virtualizes the containers, virtualizes the underlying operating system itself. The containers, this Docker, they virtualizes the operating system itself. They don't need a separate operating system like VM. That's why you cannot create containers on top of Windows operating. Windows guy would tell you need a separate VM, separate Windows operating system. So it's not possible right now. Any more questions?
Yeah, Rasun, I do have one question.
Yeah, sure. Go ahead.
So just for my understanding, so you explained on the containers. So containers just is like one way to deploy the applications. Let's say I have two apps I can deploy as a microservice on container. Now we have Docker. So Docker is separate from this microservices, and it maybe runs or install separately. But the use is just my
Docker
app.
is required
No.
to create containers.
Okay.
I'm installing Docker to create containers. Without Docker, you cannot create containers.
Okay.
Check out this diagram.
Okay.
On the host operating system, I have installed first Docker.
Okay.
Right? You can see this, right? I have installed it, right? And that's after this.
Okay. So Docker we are using to
virtualize the
sorry.
Docker I am installed to virtualize the operating system. In the physical server, you create VMs because you have installed something called virtualization software. That is where that's why you can create VMs, multiple VMs. If you do not install this virtualization software on the VM, you cannot create VMs.
Yes.
Same thing. Apply.
Okay. So Docker we use to create the container.
Correct.
And so it means Docker is one way I can say to build my image, my software, my application.
Image
deploy.
Not image, not to build image. Image can be built separately. If you have different microservices, you can have different images for that. Developers would do that. Docker is there to run those images and to create containers.
Okay, so already ready image we should have, and Docker is useful to run those images and create a container.
container.
Okay.
That's what we're gonna see now in some time. That we have Docker engine. We're gonna take the Docker image from Docker Hub, and we are going to get the image. And once we run this image, it becomes container. And that's what we will learn. How do we monitor? How do we check logs? How do we do performance monitoring of those things? We'll look at that. Of these containers. These containers are nothing but a processes, like a processes for your operating system.
Okay.
Any more questions?
So coming classes, like you will explain this creating container, like using this Kubernetes or any other.
Coming classes, I'm gonna do one thing. Coming classes, I have a detailed, since you mentioned about this class, right? I'm coming with a detailed course. I'm coming with a detailed course where I go over cloud, AWS. I talked about Linux. I talked about Docker. I talked about Kubernetes, and I talked about CI/CD pipeline using Jmeter Jenkins. I talk about all those things in this performance engineering DevOps cloud performance engineering course. If you look at this particular link, I talk about AWS cloud. I talk about Linux. If you're new to Linux, do not know anything about Linux. I talked about what all different databases AWS provides, what are the microservices, Docker, Kubernetes in detail, EKS, Elastic Kubernetes Service, Jenkins CI/CD pipeline. So whatever the current trend is happening, if you are attending the interview, you would know, many of you would agree that the questions are around this nowadays. They are not just asking JMeter. They are not just asking heap dump, thread dump. They're asking this as well. Because this is where the architecture is. And if you do not know these things, it's very difficult for you to just go and get up to speed, right? So that's where this course comes handy, and I understand this course is required, right? So that's why this course. I'm going to give you this link. I want you to go over the detail if you want, and I would like to continue with my session right now.
Hello.
Any more questions? Yes.
Yeah, so I have one question. So what about the hands-on practices for these, especially for the Docker? Like, how will we, like, whether
So,
we'll be having hands?
yes, everything is okay. So we are talking about the course itself. So everything, so I would encourage you to go over this link, and I would encourage you to go over the entire topics, and everything is hands-on. So I was about to start the hands-on right now in Docker as well, but we are answering the questions right now. Every session that you see here, this is 45 hours of session, 40 hours of session I'm talking about here. So everything is hands-on, Docker, Kubernetes, uh, performance engineering and DevOps. We're gonna cover everything. So I have shared this link with you. I would encourage you to go over this link to get more details.
And one last question also. So, like these hands-on, we will have particularly we'll have to install all the tools and all those things in our system. So you'll be
Everything would be done on the AWS cloud. We're gonna use, so the way I have the AWS account with me right now, every one of you will have this AWS account. I will guide you how to account create it, and I would do same thing, and you have to practice the same thing. Everything is hands-on.
Roshan, one more question, like is it chargeable or based on our usage, or it will be minimum chargeable?
AWS has free tier, one year, 750 hours is free. So I'll make sure that you don't incur any cost. Okay. So for learning purpose, you will not be charged if you follow my instruction during the session.
Yeah, and Roshan, are we going to use any of the APM tool?
See,
like a Datadog
right. So we are going to talk about tools which AWS offers. So like, let's say we have something called CloudWatch. In AWS, we are going to talk about CloudWatch. So AWS has out-of-the-box monitoring solution called CloudWatch. So we are going to talk about this. So this particular service is used to monitor your host metrics. We're going to talk about that. I would request,
CloudWatch is sufficient to monitor the all Kubernetes or like Docker
yes, we
pods
have
and
in the CloudWatch, we have something called CloudWatch Container Insights. And that is very much sufficient to monitor all the Kubernetes pods. We have something called Container Insights. It's dedicated for containers. We're going to talk about that.
Okay, sure. And Roshan, so do you have any updates on this? Like, if I want to do any of the integration, Datadog with the Kubernetes,
We'll talk
is
about
there
that. I
anything?
want to complete because I have 5 minutes.
Sure, sure, no problem.
I have 5 minutes, so I don't have
Sure, sure.
much time. So let me just show few things. Okay, let me complete. Yeah, we can meet for the demo session for this class. Okay, for this session we have a demo session. If you note, you can meet. We can meet at this time, 5th April, and you can ask much more detail about this particular course. And I'm happy to answer all your questions. Okay, so let me just show in 5 to 10 minutes. Let's say if I just do Docker images. So right now I don't have any images here. See, I don't have any images. So what I can do, I can get the image from the hub.docker.com. Let's say I'm going to take this image, HTTPD. It's a web server. I'm going to take this image. So what I need, I just copied this code, Docker pull HTTPD. I just hit this. And what this guy is doing, it is going to pull the HTTPD, which is a web server, Apache. From Apache, it's a web server. It's going to, it's downloading the image right now. Okay. If I do Docker images, you can see this image is being downloaded right now. This image is downloaded. Now I need to run this image, right? So what I can do Docker run -it. It's a standard format when you do. Let's say I'm going to do a port mapping. 83 port of my host, this machine maps to, I know this container runs on port 80. This particular image web server runs on port 80. So 83 port of my host maps to 80 port of my container, because I have to map my container also from my, because I can only access this particular web server through my host only, right? So I have to map this. This is called port mapping, right? So 83 port of my host maps to 80 port of my container. If I do -d, runs in the daemon set in the background, and that's my image name, HTTPD. The moment I do this, I'm going to hit enter, it creates a container for me. It creates a container. How can I verify that it's a container? Docker ps-a. If I do this, it's going to list all the containers which is running right now. I have only one container running right now, created 8 seconds ago. My web server is installed, up and running right now. It is such a lightweight web server. I can have it. I can have application server. I can have database server just like that within few seconds. And this particular web server is on hosted on port 80 right now. I can just show you where it is hosted. For that, I need to do one thing. I need to go to the security group of my AWS cloud. Let me just edit that particular thing. I need to go to the EC2, and because I need to open the port 83. If I don't open the port 83 for my, because I have used a security group for my EC2 instance. Okay, this is my EC2 instance, my server right now, which I'm using. This is my server workshop, and I have used one security group for this. If you look at the security, this is the security group. If I open this security, I need to open the port 83 as well. If I don't do that, I cannot access the page. I'm gonna show this to you. Let me just not open this port, and I'm gonna hit this. I'm gonna use the public IP. This is the public IP of my server. This is the public IP, and it runs on port 83. If I hit this, I will not get the web page. See, I'm not getting the web page. But if I open the port, right, 83 port, let me just do that. I'm going to the security group, edit the inbound rule, and I need to open the port 80. Okay, let me do the add a rule. Let me custom TCP. I'm going to open port 83, because this is where, let's say I give you anyone can access this. Okay, let's say I just web server access. I just did that. Okay, and I'm going to save this rule. And the moment I did that, if I just go and refresh it, you will see a web page coming up. See, its web page is coming up. You can also see this. This is coming from my web container. I'm going to give this particular link to you, and you can just try this. Okay, this will work. This is my web server. This is a container. It's running. I can create multiple containers. I can run a Tomcat also. Let's say if I want to run one application server. Let's say I have a jar file. to deploy, I can just go and install Tomcat. Like I just do Docker pull Tomcat and I can run Tomcat. And I have all the steps mentioned here. How do I run it and how do we create it? Similarly, I can just create a MySQL also. I can have multiple application server, multiple containers in one VM itself. I can just have it. Let's say I'm going to install not just this, I can also install Fedora, any operating system which can run as a container also. Let's say I'm going to install Fedora. I can run operating system also as a container. This is the, if you do Docker pull Fedora, it's going to pull that image for me. Docker pull Fedora, it's going to pull the Fedora image for me. And I can run this Fedora image as a container. And I can go inside this container and I can work, I can install whatever I want. If I want to install Java, I can install this, I can work. If I want to develop my application, I can do that. So what is the goal? I'm going to make the efficient utilization of the resource here. So let me just done same thing, Docker run -it. There is no port mapping required, -d, and let me just run Fedora. Okay, so this is running as a container. If you look at now Docker ps -a, you would see that two containers running. Two containers are running. I can go inside this container as well. I can go inside this web server. I can go inside that Fedora container to make some changes. I can do that. To go inside that, what I can do, I can type Docker exec -it. I'm going inside the container. I can do Docker exec -it. This is my container ID, and I can type bash. If I just do that, I can go inside the container. Right now, can you guys see that difference here? I was in the port, I was at my VM level, but the moment I hit this, I'm inside my container right now. Can you guys notice this difference?
So Roshan, right now, so container is working like a microservice.
Correct. It's a microservices is the image. Okay, I can run the microservices using Docker container. Right. So this microservice, what is microservices? This microservices is coming in the form of image. These are all our microservices in the form of image is coming. They have developed, this Fedora has developed one image, and I can run this Fedora image as a container. These are called microservices. So when you talk about modules, module 1, module 2, module 10 of your application, by end of the day, you're gonna package it in an image only. How do you package a jar file, right? Same thing, you package an image file. Similar, different technology. So right now, let's say if you're a performance engineer, let's say, now let me come out of this. Now you want to understand how much memory footprint is that taking. So you can type Docker stats. Now you can understand that your microservices is taking this much of footprint. This microservices and this microservices are taking this much CPU, this much memory. Just this much, only this much, because I'm not running anything. If you hit load, if I use this web server, let's say if you install some more web pages, and if I hit this web pages, I would get to see more CPU utilization. You can configure these things. So basically,
It's a lightweight.
Lightweight. It's a lightweight, and you make sure that you complete the resource utilization of one VM itself. Then you go with the second VM. Right? That's the main advantage. Efficient utilization of the resource. That has always been the goal. When I moved from virtualization, when I create physical server to VMs, that was the goal. Goal was to efficient utilization of the resource. That was the entire goal. That was the entire goal of creating VMs. And that's the same goal of creating containers here, to make sure my efficient utilization, because the cost matters here. You don't want resource to be underutilized. And we talk about
basically Docker images are just like the ISO images we use for virtualization.
Kind of like an image, kind of, but don't exactly. ISO images are quite heavy. If you look at this Fedora, if you let me just come out of it, if I just talk about this Fedora, this which you have installed, you have downloaded, look at the size of this Fedora. Because and you have one VM itself, because it is going to use the binaries and libraries of the Ubuntu operating system, which is where it is deployed. It is not a full-fledged operating system. because it is going to use the binaries and libraries, because it virtualizes the containers. The container engine Docker virtualizes the underlying operating system. It uses the binaries and libraries of the underlying operating system. That's the main the difference between the virtualization and the containerization. When you do virtualize, you virtualize the hardware, but when you containerize, you virtualize the operating system. That's why you don't need separate operating system, and that's why containers are lightweight. Right. So yeah, that's all for today's, guys. I hope you had a wonderful learning session today. I can hope for that, right? We can meet some other day, other time, right? And you can definitely meet me on 5th of April this time. So I hope everyone has this link. If anyone interested, yeah, we can meet that day. Any more questions I can answer before I leave? All good? Okay. I take the silence as all good. Thank you so much, guys. We'll meet some other time.
Thank you. Thank you, Roshan. Thank you for your time. It was a useful session.